Deductive reasoning. Deductive reasoning determines whether the truth of a conclusion can be determined for that rule, based solely on the truth of the premises. Example: when it rains, things outside get wet. The grass is outside, therefore when it rains the grass gets wet. Mathematical logic and philosophical logic are commonly associated with this type of reasoning. After noting several instances of essentially the same circumstances, always followed by the same result, we naturally form the general rule. Inductive reasoning. Inductive reasoning attempts to support a determination of the rule. It hypothesizes a rule after numerous examples are taken to be a conclusion that follows from a precondition in terms of such a rule. Example: the grass got wet numerous times when it rained. Therefore, the grass always gets wet when it rains. This type of reasoning is commonly associated with generalization from empirical evidence. While they may be persuasive, these arguments are not deductively valid. See the problem of induction. Syllogism. All green and hard apples are sour. This apple before me is green and hard. Conclusion: this apple is sour. This is the general form of the scientific method. Parsimony. When several hypotheses can each account for the phenomena, the most probably one, or the one most consistent with other phenomena, is to be favored. This is known as the principle of parsimony. Choosing the simplest explanation that covers the evidence. On waking in the morning and coming downstairs, one finds the teapot and silverware missing, the window open, a dirty hand on the window frame, footprints in the gravel outside. Many explanations are possible, but the evidence points strongly to a thief. This would be the reasonable conclusion. Deduction. Suppose that one goes to buy an apple and is handed one that is green. It also feels hard. On biting into it, it tastes sour. After repeating the same experience a number of times, one might reasonably conclude that all green, hard apples are sour. Abductive reasoning. Abductive reasoning, sometimes called inference to the best explanation, selects a set of preconditions given a true conclusion in a rule. It attempts to select some possible premises that, if true also, can support the conclusion, though not uniquely. Example: when it rains, the grass gets wet. The grass is wet. Therefore, it might have rained. This kind of reasoning can be used to develop a hypothesis, which in turn can be tested by additional reasoning or data. Diagnosticians, detectives, and scientists often use this type of reasoning.